Okay, this video is about complex numbers. It's section 5.6, and we are going to introduce an entirely new set of numbers, and it's a very large set of numbers. So these are the sets of numbers that we talked about back in chapter 1. We said we had real numbers. They were divided into rational numbers and irrational numbers. And then inside of the rational numbers you had subsets. You had integers, whole numbers, and natural numbers. And this was all of the numbers that we knew about so far. But actually, there is another set of numbers that encompasses all of these numbers, and that's the set of complex numbers. All real numbers are complex numbers. All irrational numbers are real numbers and complex numbers, and so on and so forth. So if you have the number 3, for example, 3, it is a natural number, a whole number, an integer, a rational number, a real number, and a complex number. If you have the number pi, for example, that's irrational, real, and complex. But now let's introduce, what are these numbers? There are numbers that are complex numbers that are not real numbers. They're called imaginary numbers. Okay, so here's a joke. You probably don't get it yet, but let me explain to you why mathematicians, why this guy right here is a mathematician. The square root of -1 is defined mathematically as the italic letter I. So this joke, all those in favor of the bill say I. This person is saying I, this person says I, this person says square root of -1, but they mean I. So it's a joke. It's funny. Haha. Okay, so an imaginary number is something like this. You have a square root of a negative number. That means you have two numbers that multiply together to give you -1. Well, 1 times 1 is 1. -1 times -1 is also 1. So there really isn't a number that you can multiply times itself to get -1. So that's why we call it imaginary. And let's move on. So what you can do is you can rewrite some numbers like square root of -8. You can rewrite this as an imaginary number instead of with this symbol. And the way to do that is to write the square root of -8 like this. The square root of -1 times the square root of 8. We'll talk about this a lot more in later chapters, but this is a perfectly legal mathematical operation. You can separate this. These are the same thing. Well, the square root of -1 is equal to I. I is the symbol that we use to mean the square root of -1. So you could write this, the square root of -8, as I times the square root of 8. That's how you write it as an imaginary number. In fact, you can write all numbers as imaginary numbers. All numbers can be written with this real part and this imaginary part. So the number 2 could be written as 2 plus 0i. You don't write the 0i because 0 times I is 0, so there's no point in writing that. But the number 2 is a complex number. So all complex numbers are written in this form. Some of them have a real part and an imaginary part, like you might have 2 plus 3i. This would be a complex number. This is an example of a complex number that is not a real number. If it has this imaginary part that's not a 0 value, then it's an imaginary number. It's not a real number. Here's another little joke. Hopefully you get it now. Okay, let's talk about imaginary numbers and what they look like on a graph. So what we're going to talk about now is a real plane and an imaginary plane. So we've used this for x and y before, but now we're going to use it to talk about two different parts of a number. So 5i would be over here at 1, 2, 3, 4, 5 on the imaginary axis. And when you talk about the absolute value of something, think back to the lesson on absolute value. What does the absolute value of a number mean? The absolute value of any number is its distance from 0. So right here is 0. This 5i, this is 5i. The absolute value of 5i is this distance, and the distance is 5. It's 5 units on the imaginary axis away from 0. So that one was pretty easy. Let's do one like this. Okay, so this is the real axis, this is imaginary, and actually I could write it either way. I could write this as the imaginary axis and this is the real axis. So I'll do that for this example. We have 3 minus 4i. 3 is how far you count on the real axis, 1, 2, 3, and then you go down minus 4 on the imaginary axis, 1, 2, 3, 4. And where they meet, this is how you would graph that point, 3 minus 4i. It's kind of strange, but that's where this number falls. It's got 3 as its real part and negative 4 as its imaginary part, and so it's plotted here. Now if we're asked a question, what is the absolute value, like we see here, that means the distance from 0 on a number line. So how far is this away from 0? Well, if you notice, this starts to form a little triangle here. This is length 3, this is length 4. So this hypotenuse is, you can use Pythagorean theorem to find it. And in this case, it's 5. So the absolute value of 3 minus 4i is equal to 5. And that's the same as our last example. So the absolute value of 3 minus 4i and the absolute value of 5i are the same thing in this case. Well, in all cases, but in both our examples, we got 5. It doesn't always end up that way. I'll do this one and that one and this one and an extra help video. So we're going to find the additive inverse of a complex number. Additive inverse, remember, means the number that you add to get the identity. So the additive inverse for this, addition, we want the identity for addition. The identity is 0. So what do we add to this to get 0? Well, you add the opposite here, and you add the opposite here. The opposite for the real part and the opposite for the imaginary part. If I were to add these together, I would get 0 and 0, so that's just 0. So the additive inverse of negative 2 plus 5i is 2 minus 5i. The additive inverse of negative 5i is just positive 5i. If you add those together, you get 0. So here's the additive inverse. I'll do that in an extra help video if you need it, but that's it for complex numbers. Now let's talk about how do you multiply complex numbers. Okay, so multiplying complex numbers is similar to adding complex numbers. You multiply the real parts and you multiply the imaginary parts. So if I do 5 minus times negative 4, that gives me negative 20. If I do I times I, that gives me I squared. Now we're not quite done here, and this is the reason why. I squared, well, first of all, what does I equal? I is equal to the square root of negative 1. That's what the symbol I means. So if I say I squared, that's the square root of negative 1 squared. If I multiply the square root of negative 1 times the square root of negative 1, the square roots go away. Anytime I multiply the square root of something times itself, it ends up being the number that's inside. So the square root of negative 1 times the square root of negative 1 is equal to negative 1. That's really important, and you're going to use that a lot in this section, in this chapter. So I squared is equal to negative 1. So I'm not quite through simplifying this problem yet. I can do negative 20 times I squared, which is a real number now, negative 1. So I is an imaginary number, but I squared is a real number. So this is the solution to our problem. I'll do one more like that. 12 times 7 gives me 84. I times I gives me I squared. Remember, I squared is equal to negative 1, so this is equal to negative 4. When you multiply two imaginary numbers together, you get a real number. Okay, now what about when you multiply two complex numbers that have a real part and an imaginary part? What you have to do is something similar to when you have a problem like this. X plus 2 times x minus 3. You FOIL it. Oops, I wrote that wrong. You multiply all of these parts out. Well, that's what we're going to do here with this complex number also. Alright, so 6 times 4 gives me 24. negative 5i times negative 3i. Well, if you multiply the real parts, that gives you a positive 15. Multiply the imaginary parts, that gives you I squared. Now we're going to do 6 times negative 3i, that gives you negative 18i. And now negative 5i times 4 gives you negative 20i. So when you multiply a real number times an imaginary number, you just multiply the real parts, and the imaginary part stays the same. Okay, now let's combine like terms. We're going to get 24 plus 15i squared minus 38i. Negative 18i minus 20i. You add the two real parts. Now I squared is equal to negative 1. So you get 24 plus 15 times negative 1 minus 38i. So this is 24 minus 15 minus 38i, which is equal to 9 minus 38i. Okay, if you still need help on that type of problem, you can do these. You can do this one in the extra help video. I'll show you the solution. Okay, now we're going to use complex numbers to solve equations. This again is an equation that doesn't have a b term, so you can solve it by finding square roots. So we're going to subtract 100 from both sides, and you get 4x squared is equal to negative 100. Divide both sides by 4, and you get x squared equals negative 25. Take the square root of both sides, and you get x is equal to plus or minus the square root of negative 25. Square root of negative 25 is an imaginary number, so we could write that like this. X is equal to plus or minus the square root of negative 1 times the square root of 25, which is equal to plus or minus I times the square root of 25. We know what the square root of 25 is. It's 5, so we can write this as x equals plus or minus I times 5. And it's a common convention to write this notation with the I on the other side. So it would be written like this, plus or minus 5i. I times 5 and 5 times I are the same thing. It's just it's more common to be written this way with the number in front. I'm going to do these problems in the extra help video.